Hey everyone, in this video, we're going to talk to you about the Home Delivery Unit, or the HDU, developed by Nestor, Chris, Adam, and George for our senior project.
You might ask why we chose this as our project. So, with the COVID 19 pandemic came an increase in online shopping and deliveries in general. Alongside this arrived an uptick in package theft. Surveys done by CNR Research, Security.org, and many others show a general increase in package theft between 2010 and 2020. This upswing has not had a pause and has continued throughout the pandemic, if not increased as well. Another reason is that groceries delivered while away from home are hard to keep fresh. The refrigeration unit on HDU makes the option much more viable. With HDU, our hope is to combat porch pirates and help keep our customers' money in their pockets.
Our product can be used by any individual. However, it is a great solution for the elderly who need delivery services because it provides them with extra assurance that they are limiting their exposures to others. Also, it is directed to individuals who are too busy and need deliveries to be made while they are at work or somewhere else. After gathering some information, we decided that this project is a good product to have for everyone since it limits exposure to others and keep everyone safe. Also, we have seen companies like Amazon now offers freshly good items. For those that live in low income areas where there isn't many resources that are being put in for protection, our product is an affordable option to counter this major concern. Our project plan was to develop a unit that provides a secure and controlled temperature to keep items fresh and safe. The unit from our project required coding in order to control the lock system and on-off switch for the power of the cooling system. It also required to wire the components correctly in order for the product to be working properly. Some key features include an electromagnetic lock, combination lock, password protection, and refrigeration toggle.
Our project development timeline went as follows. We went with an adaptive management style, allowing each member to focus on what they thought was the best use of their time at any given step of the project. Our first step was acquiring the core component of our project, the refrigeration unit. Here, a chest freezer would have been ideal, but we had a mini fridge at our disposal, so to save time and money, we used that instead. Next, we developed some simple Arduino code to use a keypad to take a password to lock and unlock the door. From there, we expanded the code to control two relays, one connected to the electromagnetic lock, the other connected to the compressor. Once the code was complete, we deconstructed the wiring of the mini fridge to redirect some of its power through the circuit we designed to power the Arduino board, relays, and lock. The implementation part of the project is when we started to have some real fun. First, we connected a keypad and LED display to the Arduino board to form the basis for our design. Next, we deconstructed the main electrical enclosures of the mini fridge and determined where we could reroute power to where we needed it. To power the circuit and lock, we implemented a small computer power supply to send 5 volts to the Arduino board and 12 volts to the lock through a relay. Then placed a diode between the positive and negative leads of the lock to dissipate the back EMF. We placed another relay between the board and power to the compressor. Once the wiring was complete, we designed two enclosures for the excess wiring, one inside and one outside the HDU. The main issue we encountered during the project was the generation of back EMF by the electromagnetic lock when power to it was switched off. When power to the lock was cut, the LED display would fail until the entire circuit was reset. At first, we thought that faulty connections might be the culprit, but after taking a multimeter to every node around the display, we had to conclude that our connections were solid. After some research, we found that electromagnets generate EMF when their power is cut. That pulse of a negative current would overload the LED display and cause it to display gibberish. We remedied this problem by placing a diode between the positive and negative leads of the lock with the forward end toward the negative. With the back EMF problem solved and some finishing touches, the HDU was complete.
Hey guys, it's Nestor Hernandez. So, before we get into the demo, I'm going to talk about these images on your screen. So, as far as who was responsible in implementing each feature, we had Adam and George work on the software side. So we used an Arduino board as the brain of our project. So they programmed the keypad menu that you can see on the center image to work with the refrigerator compressor and electromagnetic lock. As you can see, we had two options to press on the keypad, which in hindsight we could have worded better or differently, but this will have to do for now. So pound for password allows you to input a static password we set in the software as 123456 just for presentation purposes. Then you have star for control, which takes you to another menu, letting you turn the refrigeration on, off, or you can go back to the main menu, which is the menu you see right now. There were some issues in setting up a password change within the software because none of us are really familiar with Arduino beforehand, but ideally we would include that option with our final product. As far as the hardware, myself and Chris mostly handle that aspect. So one example would be when we rewired the fridge along with adding in two relays to the Arduino system to allow the board to power the compressor and electromagnetic lock simultaneously. The last thing, a major change we made in our original concept was actually the lock itself. So we originally had a servo arm and some other ideas we were going to test to lock HDU, but we weren't really sure of its trajectory. So we later got the suggestion of an electromagnetic lock, and it was the best idea we'd gone so far, so we went with it. So first, I'm going to start by showing you the refrigerator control because it will have audio and you're going to be able to hear the system turn on and off, and after that, the rest won't have audio. Alright, so the next video is going to be a demonstration of delivered groceries with the box locking and refrigeration being turned on. The next video is a demonstration of a package delivery man dropping off a box and locking it, then the end trying to open it back up without a password. Ideally, the box would also be bolted into the ground. And then the last video is going to be a demonstration of a consumer coming home to their package safely locked into HDU and unlocking it.
Now we will address what we learned during our project. First, we gained experience with the hardware and software components of the Arduino platform and refrigeration systems. Then, we further developed our knowledge of multimeters and soldering. We gained more experience with a variety of tools and equipment, including laser cutters, 3D printers, and buzzsaws. And, as a result of the aforementioned back EMF issue, we learned how to implement diodes as a solution. Finally, we will discuss potential future additions to the HDU. First, we can make the HDU Wi-Fi connected and create a mobile application that allows the consumer to control the electromagnetic lock and refrigeration while being away from the device. Secondly, we can implement a temperature control sensor, allowing the consumer to set a specific value for the inside temperature. Third, we can reinvent the physical design of the storage box and include cushioning, along with the backrest to give the HDU another use. And finally, we can implement a password change within the keypad software rather than needing updates to do so.
Special thanks to Bobby Hartsock from the CSEB Fab Lab and Professor Asan Rehani for their support. And that will conclude our presentation. We hope you enjoyed your watching experience and purchase HDU in the future.